kids, it's Miss Gamby here, and we are going to be working on graphing circles from their equations today, as well as testing to see whether points are on a circle, in a circle, or outside a circle. Let's get started. First of all, let's make sure we understand that a circle is the set of all points. It's really an infinite set of points. It says it's equidistant from a given point. That just means equidistance is equal distance. Equidistant is equal distance. And from a given point, which is the center of the circle. So I have my center of my circle, and it's labeled H and K. And as I travel, remember all radii are congruent, so every single one of these points is equal distance from that point. This is our standard form equation for a circle, standard form. And it is x minus h, the negative is in the formula, and that amount is squared, plus y minus k, and that amount is squared, equals your radius squared. Pay attention to that. In order to find your radius, which is just going to be r, you're going to have to take the square root of r squared. Square root of r squared would cancel that out. Once you take the square root, that's just going to be your r value. This h and this k are the center point. You notice them down here. Okay, so let's take a look at some examples together. We're going to write the standard equation of a circle with a center at 0, 0 and a radius of 5. Remember, our form is x minus h squared. This is standard form. Y minus k squared equals r squared. So my center is h and k, and my r is 5. So I can just start plugging in those values. I can say that x minus 0, that's that h value, plus y minus 0, that was my k value, equals my radius, which is 5 squared. Now notice the center is at the origin. So when you think about it, anything that's x minus 0 is just going to be x squared, plus y minus 0 would be y squared, equals 25. Anytime you see a circle equation where you just have an x squared and a y squared, nothing being added or subtracted within the parentheses, it is centered at the origin. So on the coordinate plane, it would be centered right there. Okay, so now let's sketch some. I've got a center at 2, negative 4, so I go positive 2, 1, 2, 3, 4. There's my center. And then it says I have a radius of 3 units, meaning I'm 3 units from the center. My radius is 3, so I'm just going to count out 1, 2, 3 to the north, 3 to the south, 3 to the east, and 3 to the west. Now this graph is stretched a little, so it's going to look funky, but remember, we're just doing a sketch. So that's just fine. It's just a sketch. Now write the standard form of the equation. Okay, I've got all my values I need for standard form. This is my h, this is my h, and this is my k. This is r. So I would start out with x minus, remember the minus is in the formula, 2 squared, plus y minus, negative 4. I got a double negative there I'm going to have to take care of. And then my radius squared. So to finish out my formula, I'm just going to x minus 2 squared. There's no double negatives or anything to take out there. Plus y plus 4. Get rid of that double negative, squared. And then I can also square 3 to get 9. There's the equation of the circle in standard form. All right, this one has a center at -2, -1, and a radius of 4. So once again, I'm going to just kind of north, south, east, west. 4, 1, 2, 3, 4. And just sketch the circle. All right, I want you to pause the video. I want you to try to write the standard form equation of this circle. Standard form equation of the circle with this is your h and this is k. Pay attention to double negatives. There's your radius. Pause the video and come back and see if you've got the answer. Okay, how'd you do? If you didn't get it right, try working backwards and see if you can come up to this answer. If not, make a note to ask a question. Let's move on to another example. Okay, we're going to write the standard form of the equation of a circle with a center 3, 0 and a point this time that's on the circle of 1, -2. Well, if I've got a circle, I know the center, I've got some point on that circle, that becomes my radius. So if only I knew the distance or the length from those two points, I would know the length of my radius. Luckily, we've already studied distance formula. So I'm going to take the distance, which is the same thing as length, and I'm going to go from my center point to the point on the circle, and that's going to equal my radius. Okay, I like to use my little T-chart. So I'm going to put my points on here. From 0 to -2 is a -2, and from 3 to 1 is also a -2. So remember your distance formula, and in this case, it's for your radius, equals the square root of your run, which in this case is -2, squared, that's your x2 minus x1, plus your rise, and in this case it's -2, that's your y2 minus y1 squared. Continue with the mathematics. I get the square root of 4 plus 4, which equals the square root of 8, which is approximately, when you put it into your calculator, 2.8. Remember, we're only going to do a sketch of the circle. So I'm still going to plot my center at 1, 2, 3, 0, and I'm just going to go about 2.8, 2.8, it's not going to be exact, 2.8, 2.8. And I'm going to sketch this circle. Oh, it got wonky. That's just a sketch. And then let's kind of just double check. Point 1, -2 should be about on this sketch. So 1, -1, -2. Yeah, about right there. So I'd say it's a pretty good sketch. Okay, write the standard equation of the circle with the center at 3, -1, -3, -1 rather, and the point on the circle is -4, -4. So I've got H, I've got K, I need R. Remember the distance from the center to a point on the circle equals your radius. So distance from to equals radius. So I'm going to use my distance formula again to find my radius. And remember, it's going to equal the square root of, we're going to put in our run squared plus our rise squared. I'm going to take my little points and put them on a T-chart. and I get a -3 and a -1 when I plug those values in. Then I can follow the math. -1 squared is 1, -3 squared is 9. So now my radius equals the square root of 10. Remember, I need to do the radius squared for my equation, so I'm going to take the square root of 10, I'm going to square it. Square root of 10 times the square root of 10 is square root of 100. So r squared equals the square root of 100. So r squared equals 10. Now I have r squared, h, and k. I'm ready to write the equation. I'm going to have x minus my -3 squared plus y minus my -1 squared equals my r squared, which is 10. Get rid of my double negatives. And there you go. Circle in standard form. The last thing I want us to look at is to determine if points are inside, outside, or on the circle. We've been given an equation. We're testing points that are x's and y's. All you're going to do is plug them in to see if your number that you get is less than 25, then that point would be inside. If the number you get is greater than 25, the point would be outside. And if the number you get equals the 25, and I'm getting 25 from my equation, that would be on. So I'll do the first one with you, and then I'm going to want you to try to do these on your own. So my x value is 6 minus 3 squared plus -4 is my y value plus 1 squared equals 25. So let's see what this is. 6 minus 3 is 3. 3 squared is 9. -4 plus 1 is -3. -3 squared is 9. That equals 18. 18 is less than 25. So this one is inside. Pause the video and try to do the next three. Plug those values in. Come back and see if your answers are correct. This one you should have ended up with 18, which is less than 25, so it's inside. This one you would have ended up with 34, which is greater than 25, so it is outside. And for the last one, you should get that 25 equals 25. So this one would be on the circle. Again, try to work backwards. See if you can get to the correct answers. And if you can't, write down some questions to either send into class through It's Learning if you're virtual, or to bring into class the next day if we are face-to-face. And that's all I have for you today, guys. Hope you have a good day, and I look forward to seeing you soon. Bye.